We can start now.
Okay, thank you, sir. Hope everybody has taken lunch. Now we are going to start our session. So already I have shared my screen to you. Sir, for confirmation, is it visible, sir?
Yeah, is it visible, sir? Can you put it on full screen?
Yes, yes.
Perfect, sir.
Okay, fine, thank you. So in a coding part, morning session, we have seen how we can get data sets. As I said, the Kaggle is the preferred one. And importing libraries, so NumPy and Pandas we have used, and how we have imported using import command, we have seen it. And how the data sets can be imported, that also we have seen. The missing values, here the missing values means if the data set someone has entered, and if for any particular instance, say for example blood pressure, if he has not filled any data, so that is called as a missing data. But if he has filled the 0 value at a skin thickness, that is invalid data. That is not a valid data, because the skin thickness cannot be 0, as I said before. Now the encoding, categorical, splitting data, and feature scaling, these things, and the wrangling data, we are going to see it in our code itself. So we'll interact with the code, and then so my Jupyter notebook is visible to you, sir?
Yes, sir.
Okay, fine, thank you.
It's visible, sir.
Okay, fine, thank you. I'll start my previous sessions. So I'll again, suppose once you have clicked and save, your file will be saved here. And I said this thing will be automatically saved. You need not save it. So while you open second time, just to click here on your file in a root directly, your code will be open here, and you can see the everything will be saved automatically. You need not save again and again for each and every time. So now I was here. Is null. Is null is a command which shows you that how many instances are null, has a null values. So in this pregnancies, glucose, blood pressure, skin thickness, it says that there is a 0 value which is a null. What does it mean? It means that there is no null value. So is null gives this kind of information. Now in the next line of code, I'm going to import the NumPy. NumPy is another library. It's a stand for numerical Python. Numerical. It is used for numerical analysis. And the way of importing is import NumPy as NP. And what I'm going to do, the DF is a data frame, has my diabetic data sets values. Now I'll make a copy of this. So how to make a copy of this? As DF is a one variable, previously I have given. Now the DF underscore copy is another value, is another variable. And the command for copy is copy in bracket dependent equals to true we have to write. If you write false, it is not going to copy it. Okay, so we'll write as a parameters deep means dependent equals to true, and the df data sets will be copied to the data df underscore copy. It is going to copy. Now, what is my main motto here? My main motto here is to replace the zero values. So wherever the values are called as zero, that I'm going to replace with the NaN value. So how to replace it? And I'm going to replace in a 5 instances only. So what are those 5 instances? The glucose, blood pressure, skin thickness, insulin, and BMI. Only on these 5 instances, I'm going to apply the replacement. Okay. So here the df underscore copy, and this is a list we have used in array. That array, the same in Python we use as a list in a square bracket. So this is the instances equal to df underscore copy and same instances, and I'll use dot as a concatenation. I'm going to replace it. After replacing, so these values, this right side value will be replaced and it will be assigned to, here is the assignment operator, the same value will be assigned to the left side, right? First, the right side value will be assigned, means replaced, and the replaced value will be assigned to left side, which is in glucose, blood pressure, skin thickness, insulin, and BMI. So that is the work of this code, and how to replace it and what to replace. Here is a object called replace, and what I have to replace, the zero value I'm going to replace it with what? With a NaN value, with NaN value. So before it was coming here as a 00. Now when we same code, if we run it, we have seen that the glucose has replaced with a NaN, how many? 5. And in blood pressure, how many 0 is replaced with the NaN? 35. Before it was not. Look here, all are 0 here. Whereas after replacing, I have run the same code. And it shows that the 5 value has been replaced. 35 for blood pressure, 227 for 374 for insulin, 11 for BMI. What it actually depicts, what it shows you, it shows that actually it's a huge data. It's a 768 data. So while seeing, we cannot identify where is 0. If it is suppose 1 lakhs data, it is not easy task to look how many missing values are there, how many 0 are there. But using a single line of code, you are going to identify how many zeros are there and how many errors are there, how many invalid values are there. So just with a single code. So that is the magic, that is a beauty of this Python. So now next, if I wanted to check whether it has been replaced or not, morning session, I said already the same command you run on a df underscore copy, because all your data sets are in df underscore copy dot head. Head will print 5 rows at a time. The first 5 rows, and tail will print last 5 rows. So now before replacing, there was no NaN, insulin. While we replaced, here we got NaN. So we can see this NaN easily that, okay, there is no value. So this is what the analysis of data is all about. Now, if you wanted to see for a cell, just add one cell, click plus, and write it down here, df underscore copy, and just give here, and you write it in a cell. So this cell will give you df underscore copy, dot tell. Copy is not defined. Okay, yeah. One more thing. It's good to have an error here. Uh, Here, if you get this kind of error, something like a not defined, think that your variable which you are using uh, is not executed. So what you have to do, wherever the df underscore, where you have copied uh, here. Yes, you have copied here, right? So you can execute it once. So you execute it once. Here the df is not defined. So wherever the df you have defined, so where you have defined, just go upside and look where you have defined df. So you have defined df here. Yes, you have defined your df here. So because df equals to pd dot, so you have to execute once this one, execute once your library, this library, panda library, you have executed, and then again you execute this also, and all these you executes. And now, because we have closed this one, now when you go to describe, we have to execute again and again. Okay, while you start your new session, we should always execute it. Now we got this one, and we executed this. When you come to head, this you execute it, and now come to tail. Here we were getting error. Now you see, now the error will not be there. Why? Because we have executed that df underscore copy variable instances. So now you can see that error has gone. So what you got with this? If you get something like some code is not defined, go directly on top, because you have defined your variable on a top, that you execute it once, because that thread has to run in a background. All the variables, all the instances the df has, and the df is not executing in a background, so that has to be execute. Then only this is going to execute, because the df underscore copy has a copy of df itself. It has a copy of df itself, and df has not executed, so that has to be executed. So that's why now you can check it, the error has gone off now. And if you observe it exactly, and a 764 rows, there is a NaN values, right? While seeing NaN, because it's a different than number, it's a some kind of alphabets. So easily your eyes can go to that place. You can find that, oh, it's a invalid value. It's an invalid value. So that is how you can identify your invalid values. Okay, so now come to the data visualization. What is this data visualization? Say we have errors at 766, and some columns, some rows, or some instances have invalid values. Those values are not easily captured by our eyes. It cannot be captured. If millions of data are there, lakhs and lakhs of data are there, and you can surprise to hear the Python Panda executes millions of data in a fraction of second, fraction of minute easily, whereas other like Oracle doesn't do like that. So that is the beauty why the machine learning is a more prominent today, and each and every sector, either the government sector or private sector, are using uh, machine learning. Even you'll happy to know Google uses artificial intelligence, machine learning in each and everywhere, each and everywhere. If you talk Gmail in spam filter, if you talk Google Lens camera, there also you can see speech recognition. Everywhere Google is, because the Google has identified that the machine learning is only the future, artificial intelligence is only the future. All the things are getting isolated or maybe getting slow, and everybody want their works to be done very faster. So the machine learning is for us. So the data visualization is something like a pictorial representation of your data sets. We have seen the data sets. These are the data sets, which is in tabular format. It's in tabular format. But our eyes always love to listen, or sorry, love to love to see pictorial representation. So while seeing the pictorial representation, we can easily say that, okay, this is a error we have. So the data visualization takes place. So data visualization have a different data visualization. We can have a histogram, we can have a chart, we can have a line, we can have a scatter plot. So many plotting techniques are there, and all the data visualization are predefined under matplotlib. Matplotlib. So matplotlib is one which is used. Now you can just see I have used here df, which is a first variables, and hist is stands for a histogram. I want a histogram to be designed, and the figure size I have given a 10 to cross 10, yani ki x axis 10 and y axis 10. So if you execute it, so here you can see the you can see the data, you can see the it's not coming. Why it's not coming? Because I have not printed it. Now what I'll do, the same thing, if I print it with a copy, now you can see your histogram here. For for each and every instances, we had age, we had BMI, blood pressure, insulin, glucose, and other instances we have. So total 9 instances we have, and for all the instances, here is a histograms. Look the histograms, and while seeing this histogram, you can easily identify the errors in this. Right now, we have designed this for a DF. This is for DF. Now the same diagram will design for if it is for copy, then how it looks like. Okay, this is for copy. The implement NaN means okay. So this histogram is for with error. This histogram is with error. So while seeing what is that error? Error is might be this is separate from this one, and error if you find in skin thickness, because the skin thickness has so many zeros, which is invalid. So see, this is the diagram for a skin thickness without replacement, and when we see the skin thickness with replacement, so this is the last block. If you see, you can find the difference. See here, see these hypes are there, and where here there is no hypes, there is no much hypes. So this is how the data visualization looks like. And scatter plot, you may have so many pie plots, we have line diagrams we have. Okay, so by using this, you can see your data sets very easily. Okay, now see, okay, now so how this NaN, how this NaN can be removed or can be replaced. So we are going to clean our data. Now, how to clean the data? What is meant by cleaning a data? Cleaning data means we have something called as a something called as a uh, zero value. Zero is an invalid value, right? That invalid value has to be replaced. That has to be dropped. It should not be there in that. If the zero is there, and if you are making a model, that model will not predict correctly. Say, for example, if you see your weather forecast for this place, and if you really observe what's the temperature, and the temperature will be, say, 17 degrees C. If you keep your thermometer here and see the temperature, it gives you the different values. But that different values and this 17 degrees C will not have a much difference. It will not have a much difference. But if you give wrong values, wrong data sets to the machine learning code, then it predicts wrongly. So that's why that zero has to be replaced with a some value. So now what it has here, it has done, it has transformed, and there is a techniques called as a scaling. There are two kind of scaling techniques, and what is meant by scaling, let us understand. The scaling means wherever we have something called as a zero, and whatever the value whatever the value we have, that has to be standardized. What is meant by here standardization? Standardization means bringing that values, so many values, to or in between 0 and 1, or you can say near to 0 and 1, or zero near to 0 and -1. So that is meant by standardization. And why this has to be done? Because there is a huge scale between this one. If you look here, say for example, if you take glucose value is 148 for a zero, for a zero column, for a zero rows, and for second it is 85. So what is the range from 85 to 148? Huge gap. You can find there is a huge gap, right? 80, where is 85 and where is 148? There is a huge gap in this. This huge gap has to be filled out. There should not be much gap. So that is why we use the scaling. That scaling brings all these data into the smaller one without disturbing the values. That is a beauty of the scaling and the standardization and normalization. Here is a code, and the standardization use and sub libraries called as a standard scaler, and the libraries are a sklearn, which we have used here. From sklearn, uh, dot processing import standard scaler. This is a library, and this is a method where the formula for standard scaler is predefined, that has to be assigned to st. St is what? St is some variable. St is a some variable which I'm going to assign all the features of standard scaler. And for a standardization, we use this method called standard scaler. And whatever the features, what are the features are there? There are two features. The features like how to calculate. There is a formula called mean divided by certain values. So x mean minus some instances. some particular instances. So this variable, this formula is also predefined, as well as the fitting the value into in between 0 and -1 also predefined. So that is what we have assigned into ST, and I've used here as a data frame, pd dot data frame. Here pd is a Panda library, and dot is a concatenation. A data frame is used to fit the transform. And how I am going to fit? By using the fit underscore transform. What it is going to fit? It is going to fit my values. It is going to fit my values. So what kind of values? All the values which columns has a pregnancies up to age. So these are the values from pregnancy to up to age. I'm going to fit it. And what is this one? df underscore copy dot drop. This will drop the columns called as a outcomes. We are not going to fit, we are not going to scale the outcomes. यानी कि जो output है, we are not going to scale it. Why we are not going to scale it? That value is a fixed one, because that's the output. Based on input, that is the output, that we are not going to scale it. Okay, only we are going to scale the features, the values, not the outcomes, right? So that's why we have used here the drop. Drop will use to drop entire columns value. And what is that column name? The column name is outcomes. So the outcomes of df underscore copy will be dropped. And how many axes is to be dropped? Only one axis is getting dropped, and this is a columns which that it is going to drop it. And by using x dot head, I'm going to print it 5 values after dropping the outcomes. So if you execute it, you can see here the 5 values are there, but right now all the values has been scaled it. All the value has been scaled it, right? You can look here, you can see the pregnancies at a 0 level, it's a 0.639947. So it is in between 0 and -1. If we talk the another values, in a 1, it is minus 0 point something. So that's what it has been. That is what we call as a scaling. And we have dropped what? We have dropped the outcomes. So last, you can see there is no outcomes here. The only up to age we have. The outcomes has been dropped in this. So this is what we have 4. If you want some more data sets, as I said, DF, and in a list, you can write 40 to 50, 70 to 80, or 100 to 200. All the values you can, if you want, you can see it. So let me show you. So it is from the df underscore copy, right? So df underscore copy, and we take the list. I want 100 to 120 value. I want only 20 values. So if you execute it, just to see, and all the values you have here, it is not the scaled one, right? If you have here something like just a minute, df copy, here if you write, just if you type it 100 here and you execute it, so you can see 0 to 100, 0 to 99 values. So 100 rows are there, and all the 100 values are scaled. All the 100 values are scaling. Scaling is nothing but changing the value or fitting the value, whatever the previous values were there. Just see the previous value, how it was looks like. Look here, how the previous value. So this is the value which was looking like, and this value has a huge gap between 101, 120, 122, 1 somewhere 93, 70, and one value is 0. So there is a lot many variations from 0 to 101 or 0 to 122 or 0 to 121. There is a huge gap in this, right? So this gap has to be filled out. That's why we have used here the scaling techniques. This scaling techniques is very useful for all the research scholars students who are doing it, because without this scaling our data is not going to predict very correctly. Okay, you can see huge difference between the values. If you see the differences between 1.11 and 0.5, there is no much gap in this, much variations in this. So that's why the scaling is used. Here I have used only the standardization. You can use normalization also. I have not used here, but I'll tell you the normalization. For normalization, we use min-max scalar. Min-max scalar is a sub-libraries which you are going to use in sklearn libraries, and you are going to use the same way from sklearn. How you can import min-max scalar? You are going to use from sklearn dot processing import min max scalar. For min max, m is a capital, max m capital, and scalar s capital. And we can write it here min max, and all the features will be saved into one variable, and you can print it in the same way. So this was about how we can scale the data sets. Now we are going to build a model. Now how to build a model? So just for a confirmation, I'm audible, sir?
Yeah, you are audible, sir.
Okay, fine. So now I'm going to build a model. Why we are going to build a model? As in my slides I say, we are going to give a training to the data sets. Sorry, by using data sets, I'm going to train that model. Based on that previous data sets, the new data sets, if someone gives, it will predict. So that is why we use to model. Okay, how we can start it? We are going to start with a splitting. We are going to split it. What does it mean by splitting? As somewhere I said, there is a dependent variable and one is an independent variable, right? So dependent variable and independent variable has to be separated, right? X and Y, say x is a dependent variable, Y is an independent variable. So this two has to be separated. This two has to be separated. How we are going to separate it? I will use here x as a variable. Any variable you can take. It's depends on you. And now write it here df, because df has all the data sets of diabetics, and dot drop outcomes x is equals to 1. What does it mean? From the data set, outcomes row outcomes columns will be dropped. Drop means it will be removed from the list. It will remove from the list. Okay, and it will be assigned to what? It will be assigned to x value. Again, df and outcomes. So outcomes is dependent, draw and without outcomes are the independent variables. So these two variables has to be separated. And now I'm going to print it x. If you print the x, you can see your all the values are having the without outcomes. So see, I'll go to last and see there is no outcomes over here. There is no outcomes here, right? There is no outcomes because the outcomes has dropped. If you talk same way, if you print it y, the only Y is not defined. Y is not defined. Okay, see now the y has an outcome value. So look here, all the outcomes value it is displayed here. Total 768 values has been printed here with the y value. So these are the outcomes. 1 stands for with diabetic and 0 stands for without diabetic. So this is what how we can split our data sets and look, only 2 lines of code are used to split. So that is again and again, I'm forcing you. It's a very beautiful platform. I'm encouraging you. Please, you can use it. Everyone must use, because it's a just use 1 or 2 lines of code and so many works it does for you. Okay. Uh, so this is a y value. Now next, what I'm going to do, I'm going to split the x value and y value again. I'm going to split x value and y value again. What does it mean by, what is mean by this one? See, as I said, the each and every program has to be trained. Means each and every algorithm has to be build a model, and first, before building a model, it has to be trained. So we have to give a training. What does it mean by training? Just remember that kid as an example. When kid wanted to touch that flame, ultimately he touched once. And after that, the second time he was thinking, wondering whether I should touch or not. How it happened? Because his brain has trained. And now he is thinking the past, thinking from the past that, oh, if I touch, then again my hand will harm and I'll cry. So he has remembered, or she has remembered from the past experiences. So that is what is called as a past experiences. How we can train this code. So that is what we call as a training. We have to train our model first. On what? On our these data sets. On our these data sets. First, each and every dependent and independent variable has to be splitted into 2 categories. The first is a X train. Look here, X train and X test. Y train and Y test. There are 4 variables: X train, X test, Y train, Y test. What is this one? So X is divided into 2, training part and testing part. Again, Y value has been divided into 2, training part and testing part. What is this training and testing? For a training part, we are just giving a training to that model, to build a model, and we are going to test it. We are going to test it, right? So whether the training is done correctly or not, how we can know? While testing it. So that's why for x-axis there is a 2 split, training part and testing part. In a y part also, training part and testing part. And one more thing you should know, it has to be mentioned that what is the split ratio, how much splitting ratio we can have. You can split 60 by 20, sorry, it's 100%. So you can split 80 is to 20, 75 is to 25. And this ratio can be converted into decimal values. And by using a object method called train test split, train underscore test underscore split is a method which is going to split this one, x value and y value. So look here, this is a variables, all variables. Left side are all variables. and this is a method. Train test split is a method which is going to split, and x and y values. X is a dependent and this is an independent variable, right? Now here the test size is 0.33. What does it mean by this? Test underscore size is that ratio what I said. You are going to divide this into a specific ratio called 75 is to 25, 30 is to 70. So this ratio has to convert into decimal. So that is what this ratio is all about, 0.33. 75 is to 25. And here is the random state 7. Random state 7 means, let me execute and then I'll tell you. So first you execute it this. Okay. So how you can execute? Again, I repeat, shift plus enter, you can execute it. And while printing each individual, you can see here only 14 rows are there in this. You can see total data was 768, but after splitting, the X train has only 514 values, and the X test. So here is a X test. If you print it here, so total how many values? 254. If you add this 254 with this 514, so it will be 768 total. So that's what is the splitting has been done. So it has done with that ratio, which the 0.33 has been provided. So X train is 514 and the X test is 2, 254. The same way, we have another two variables called as a Y value also. So Y train, if you execute it, how many values are there? This also have total 514 values, and the X test will have, again you have 254 value. If you added this both to 514 and 254, it comes near about the total data. If you observe one more thing, if you X train, Y train, sorry, X train and X test ratio, and Y train and Y test, the ratio are same, and the number of rows and number of columns are same, right? Here is a 514, above also it's a 514. Look here, above also in a 514. What does it mean? It means that the x-axis and y-axis which is going to split will be in a same ratio. For x also it is same, y also it is same, because we are going to use for a training purpose. We are using for a training purpose. So here is a splitting has been done. Now I'm going to use algorithms. As I said in PowerPoint slides, there are various algorithms. We have so many algorithms here. In this, I have used one algorithms only, SVM. Maybe I have used SVM. Yeah, I have used SVM. Only one algorithms I have used. You can use it, all the algorithms, and you can check it out. You can make a model, you can get the result. So, as I said, each and every algorithm is predefined under sklearn. You have to remember always, all the algorithms are predefined under sklearn. Sklearn stands for sklearn. Sklearn stands for sklearn or sklearn, you can pronounce it as. So how you can import these libraries, because I'm going to use the algorithms support vector machine. Here is a method which have all the features of SVM. It categories, it classifies the values into two. It clusters the value into two, and there will be a Gaussian plane and all these theoretical parts you can study. So that's what. So the mainly SVM classifier classify the two classes. One is class 1 and one is class 2, and there will be a Gaussian plane that divides these two classes, and I'm going to fit those two values those two values into this by using this diagram, by using this algorithm, sorry. So how we can use it? This from sklearn.svm import svc. Svc is an variable, any object. sklearn is a library. So this is how we can import this library for svm, and it is not like other algorithms that we have to write a number lines of code for each and every algorithms. No, in machine learning, just use SVM of SVM and in function. That's it. The rest works machine learning Anaconda does. So that is the beauty of this. Everything is predefined under SVC, and these SVC features are assigned into SVC with a smaller letter, and SVC.fit. Here I'm going to fit this one. Fit means it is going to transform the values, X value, X train and Y train. So I'm going to give a training to the SVC. What I'm going to give? Listen here carefully. I'm going to train it, my algorithm. What algorithm? SVM algorithm. Where is an SVM algorithm? Here is an SVM algorithm. SVM of. This is a algorithms which is a fixed one. It will be in capital letter always, and I'm assigning into smaller. And here I'm concatenating it. SVC dot fit, and I'm going to train that. Okay, so I'm going to train. And where is the data to train? Here is the data to train. X train has a certain values, Y train has a certain values. If you execute it, so here the training is done. Now the output it has given here, it shows that your training has been done. Now, if you really want to test our data, yes, you can test it here once you execute it, and now calculate the value of that. You are going to calculate what is the accuracy of these algorithms. So if you execute it, sklearn import matrix, and you are going to print the accuracy of SVM using accuracy score for a Y test and SVM prediction. Then this will give you the accuracy, how accurate this algorithm is. So you are going to use not only a single algorithm, because my data sets are good for which algorithms. We have to use all the algorithms, or 5, 6, 10 algorithms you use simultaneously to compare your data sets are working fine, or which data sets, which algorithms gives a good accuracy score. Because here in this accuracy scores are 0.6377. So this is the accuracy score for SVM on a given data set. If I use k-mean algorithms, so the accuracy will be different. Now, those who has a good accuracy, that algorithms works fine for that data sets. That is what we have to use, and this is what the optimization we are doing it. So in optimization, we look for a best one among so many. So this is a one way of identifying the best one. We are using, say, k-mean algorithm I am using, and the accuracy score is a 0.75, and I have used here SVM classifier, support vector machine classifier, and the accuracy score is 0.63. So which is the best one? I'll compare it. So definitely k-mean has a best one because it has a 0.75. So I will write my research on that. that this algorithm works fine for this kind of collected data, and that data should be either the primary one and or again the secondary one. Now I'm going to predict now whether my uh, machine which has been trained is predicting correctly or not. So you can see here, I have given here the instances. What instances I have given? I have given here the value. I have here given the pregnancy, first instances value, second instances, third instances, fourth, fifth, sixth, seventh, eighth. All these value I have given. Here I have not given here as an output. I have not given here as an output. Now this will predict output automatically because this machine has trained. I have given the output, I have given the training data before, and the machine has learned now. The model has generated, the program has generated, and that program will work on these data sets and predict the result. So if we execute it, you can find the array 1. Array 1 means the person has a diabetic. Person has a diabetic, right? So by this way, we can take one more values, few more values we have, like we'll go top, we'll take the data sets and then we'll predict it. We'll take these data sets, we'll take this one, we'll take this one. Okay, so 18566. Again I'll go here, just you can copy this one. So here is the person have a diabetic, the result is diabetic. Now I'll add it one more and I'll paste it here, and this value I wanted to replace it. So let it replace it. I am going to use it. For reference, I'm keeping this one. The how many values are there? 1, 2, 3, 4, 5, 6, 7, 8 values. Okay. So let me remove this one also. So here all 8 values I will paste it. Okay, I'll copy that first. First I'll copy these values. One value I'll copy, one value I'll take which has no diabetic, right? And I'll see whether it is predict 1, 2, 3, 4, 5, 6, 7. Okay, this one I'll take it and I'll check it whether it predicts correctly or not, because here I'm seeing the outcomes are 0. 0 means no diabetic. So I'll copy this one data sets and I will paste it here. It's not getting paste, so I have to write it. Wait, I will write this one. I will write and then we'll take one values like 699. Here the first value is 4, then 118, then 70, then we have 0, again 0, then 44.5, then we have 0.90, and we have 904, and then next we have 24. So this is 1, 2, 3, 4, 5, 6, 7, 8. So 8 values I have taken. So let us see what the output comes for this. So we have here 1, one more square, we should write it here, and the value is 4 comma 118 comma 70 comma 0 comma 0 comma 44.5 and comma another value is 0.904 comma 24. Okay, so now we'll see whether what the value it gives. So again, if you execute it, you can find that the person has no diabetic. So 0 means no diabetic. So this result comes with the past experiences. So how this the result is? The result is because of the past experiences which we have given the training. So this is how the backend looks like. For the front end, you can design it by using tkinter. This is additional information. So any other days, I'll tell you how this can be pictorially looks like. If suppose there is a 5 fields for each and every one, and the person, any person in the globe will type it their pedigree function, pregnancies, or some values. There is a fields, one page will be there. In that, they will fill it, and with a one click, they can find that the person has a diabetic or not. So this interface can be designed what we call as a front end, because the user is going to interact with the front end, not the back end. This is a back end code which we are doing it. And a front end by using tkinter, or somebody called it as a kinter also. You can use kinter for a front end, and it's used in Java, it's used in a Python itself. It's a Python tkinter, you can say. And TensorFlow is a library. TensorFlow is a library which is designed by, used by Google itself. The TensorFlow is designed by Google itself by using some organization, and it is using and doing the beautiful things in machine learning. So this is all about the seminar, webinar. Now we'll have a question answer session. If you have any queries, we can take the queries, and your further details about certificate and questions and all, everything will be discussed in this session itself. So over to you, Vikas sir. If anybody have queries, they can ask, please. Hello. Vikas sir, are you there? Hello. Can you hear me? Anyone raise the hand if you hear? Anyone can raise the hand if you are hearing me? Okay, fine. Thank you. Thank you. Thank you so much. Thank you so much. So if you have any queries, if not, then let the Vikas sir come. Vikas sir, are you there? Okay, fine. If anybody has a queries, you can just post me through this sarojkumargupta@gmail.com. I'll solve your queries, and the certificate will be based on your questionnaires. You'll get a link for that. If you reply to that, you'll be getting your certificate. So you maybe this week or maybe another week, you'll be getting your certificate in your mail. Vikas sir, are you there? Vikas. Acha. Okay, thank you so much. So my mail ID is sarojkumargupta@gmail.com, and my number is given 8512878482. If you have any queries, you can yeah, I can understand. If you have a questions, you can post it through my mail. I will solve this questions and I'll reply to you. And with this from my end, I have given you a little bit ideas. It's not a much ideas, but I have encouraged you. Just I wanted to encourage you to use machine learning and Anaconda for your project. All the MTech students, BTech students are wondering how to use and what to use. So this is a basics idea I have given you, how you can start it. Even the research scholars can start like this. Thank you so much. Jai Hind. Thank you so much.
Sir, I think Yanendraji wants to ask some questions.
Yeah, okay. You have come, sir. Hello, sir.
Sir, you can unmute yourself and ask the question.
Yeah.
Hello.
Yeah, yes, please tell.
Yeah, yes, sir. Saroj sir, any feedback form for this?
Yeah, there will be feedback. I'm going to give you. It will be in your mail. Just to reply it, you'll be getting certificate by that.
Okay, sir. Sir, thank you very much.
Thank you so much, sir. Thank you so much. Any other queries? You can unmute and you can ask.
If participants, if you have any questions, you may ask. Otherwise, we have to conclude the session. Gupta sir, I think we have to conclude.
Yeah, thank you so much.
Thank you, Gupta sir, for sharing your knowledge with us.
Thank you so much, sir.
Thank you all the participants to join us.
Thank you so much, Vikas sir. Without you, this could have not been done the successful. And all the credit goes to Vikas sir, who is a training and placement officer in RPS group of institution. Thanks a lot, sir. Thanks a lot.
Thank you, sir.